Okay, hello students. Today we are going to start module number 4. Today we are going to start module number 4 of your Dsdv using digital system design using Verilog. So what is module number 4? Module number 4 is the I/O interfacing. So into this unit we are going to discuss about the I/O devices, I/O controllers, parallel buses, serial buses, or serial bus protocols, serial transmission, then I/O software. So out of this we are going to start. First point will be the I/O devices and I/O transducers. So you know that various input-output devices we are going to use. The input-output devices are nothing but your transducer. So input device is nothing but the sensor, and output device is nothing but your actuator. So these are going to convert one form of energy into another form. You know that the transducer. So transducer convert real world information or real world effects into the digital form, or digital form into real world effect. So input transducers are nothing but the sensors, and they will require sometimes they will require the analog to digital converters, and in case of output transducers, actuators, they will require digital to analog converter. Okay, so while interfacing, so human can interface various devices. Like input devices are the buttons, switches, knobs, keypad, mouse, etc. And the output devices are the LED, indicators, displays, speakers. These are the output devices we are going to use. Okay, so then we will come, that is keypad and keyboards. Okay, so push button switches are also used in keypad. So we can use likewise here. You can see here push button switches are used in keypad. So for example, phone, security system console, automatic tailor machines, and other applications. The key switches are arranged in a matrix. So you can see this matrix in the figure. Okay. So this is matrix. There are 4 rows and 3 columns. So the switches are placed like this. Okay. When all the keys are open, at that time, so every column is connected to high voltage, that is VCC voltage. Okay. And when a key is pressed, one column line is connected to the row line. Okay, the matrix is scanned by drawing one row line at a time, leaving the rest of the other row lines pulled high. One line will be low and then other lines will be high. Okay, now let us see if we press a key 8, then if we press a key 8, C2 is pulled, column C2 is pulled low when R3 is driven low. If more than one key in a given row is pressed at the same time, all the corresponding columns will be pulled down. Okay, so thus we are able to determine some information about which key is pressed. We will be able to get information about which key is pressed. Okay, so in this way we can sense which switch is pressed. Okay, thus to drive the low line or counter together with the circuit that stores the count value and the column line value for the access by the embedded software used. Okay, so embedded software will running onto the processor, and that need to scan matrix periodically or repeatedly. Okay, so similarly we can use or we can detect the push button. So here, so there is some problem. So we need to synchronize this output. So to synchronize this output, one approach is there. A simple approach to provide a register. Okay, we have to provide a register onto the input side and as well as on output side. So you can write values to driven the row line or column line. Okay, for the processor, and the processor will read that which row and which column will be there. Okay, so the embedded software will take care about this. Okay, then next point, the knobs and position encoders. Okay, so in an analog circuit we will use a variable register. We can use a variable register for what purpose? We can use variable registers to detect or to increase value or to decrease volume. Okay, so but in case of digital system, this knob is replaced by push buttons. So you can see into the amplifiers. Nowadays the amplifiers will get the two switches, that is one is for increasing volume and one is for decreasing volume. So volume up and down switch are used, and it is not easy to use the knobs. Okay, so there are also sliders are used. Okay, so we can use a position encoder attached to a knob. Okay, so how we can use a position knob? Okay, so one digital knob input uses a soft encoder. This form has the advantage that absolute position of the knob is provided as the input to the system. However, a simple form of input devices is an incremental encoder. So determine the direction of the speed of the rotation. Okay, so what is that incremental encoder? So you will get the diagram of the incremental encoder. An absolute position in an important incremental encoder is a simpler. Okay, so an incremental encoder has also be used for rotational position input in an application other than user interface. Provides absolute position is not required. It can also be used as a rotational field. Now you can see here an incremental encoder operate by generating two square wave. Okay, so now you can see here there may be an optical encoder or optical sensor or the mechanical sensor will be there. So light will be fall onto the particular line. Okay, and then we can detect so in which direction it is going to be flow. So in counterclockwise direction. Okay, A is leading and B is lagging here. Okay, and so if rotates in clockwise direction and counterclockwise direction, and if they are rotated in clockwise direction, then you will get A is lagging and B is leading. Likewise, you will get the output here. Okay, so another devices that is we are going to use at the input side, analog inputs. Sensors for the continuous physical quantity are very greatly. Okay, so physical effects that are converted into the digital form, or any electrical effect, any physical effect, any physical change that will be converted into the analog voltage or analog current. Okay, so the various devices, they are nothing but the sensors. Okay, so in most of the sensors, the signal level is small and that need to be amplified before applying it to the digital circuit. Okay, some of the sensors, they are like, here you can see here the microphone is there. So microphone, these are the among the most of the common sensors in our everyday life, and it will include in digital system such as telephones, voice recorders and cameras. Microphone has a diaphragm, it will have diaphragm, and it will act as a one plate of the capacitor. So there one is a fixed plate and another is a movable plate, and you will get the, due to the sound there will get vibrations and you will get the change into the capacitance, and hence we can sense the analog information, that is physical information, into the electrical one. Okay, so then you will get another device, that is the accelerometer. Okay, another input device is an accelerometer, are used for the measuring acceleration and the deacceleration. Okay, so a common form of the accelerometer in an automobile, so it will be used in automobile, it is for airbag controller. For example, has a microscopic cantilevered beam manufactured on a silicon chip. Okay, so another example of the input devices is the fluid flow sensor. There are numerous forms of the sensors that rely on different effects to sense the flow. One form uses temperature dependent resistance. Okay, one form of flow, it will uses the temperature dependent resistance. Two matched resistors are self heated using an electric current. On the resistor is placed into the fluid stream which cools it by an amount of temperature. Okay, since the resistor depends on the temperature, the difference in the resistance between the two resistors, that it will measure the flow rate. Okay, the resistance difference is detected to drive the analog input signal, and in this way we can detect the flow or rate of the flow. Okay, so another input device we can use gas detector. Okay, so there are numerous forms of the sensors that are used in different effects. Okay, an example of photo ionizing detector uses ultraviolet light to ionize the samples. Okay, it will be used, they are used for safety equipments, they are using for safety equipments. Okay, the current in the path depends upon the concentration of the gas and the atmospheric sample. Okay, the current is sensed and amplified, and it is used to control the various devices. Okay, so that's all about the today's video. We can stop here for the today's video, and then in tomorrow's video we are going to discuss about the analog to digital converter. There are some forms of analog to digital converters. Okay, so today we will stop here. Thank you.